warm-up today is going to be the 21 game, which I think we might have played before, but I will go over the how you play the game. So what you need to do is you need to get a dice, a 6-sided dice, and throw it 4 times so that you generate 3 numbers. Now what you have to do is to come up with a calculation that only uses these digits to make all the numbers from 1 to 21. So if I show you what I might do with these digits, you can then give it a go yourself. So to make the number 1, very simple, I could do 3 subtract 2. To make the number 2, I could do 5 subtract 3. To make the number 3, I could do 5 subtract 2. Now to make the number 4, I'm going to do something a little bit different. I'm going to take this 2 and use the other 2 as the squared sign, because 2 times 2 is 4. 2 squared is 4. To make the number 5, I could do 3 plus 2. To make the number 6, I could do 2 times 3. To make the number 7, I could do 2 squared, which I had over here, and then add the 3. To make the number 8, I could do 5 plus 3, and so on. So you then have to make all the numbers up to 21 just using these 4 digits. Now in any one sum, you can only use these digits once. If you don't have a dice, don't worry. You can use the 4 numbers that I've just thrown. And if you really want to give yourself a challenge, just throw 3 numbers or use these 3 numbers. Good luck. Have a look at these triangles, which have been sorted into a Venn diagram. How do you think they have been sorted? What label could you give to the circle on the left? And what label could you give to the circle on the right? Stop the video and have a think about this. Perhaps you spotted that all of the triangles on the left-hand side are right-angled triangles, and all of the triangles on the right-hand side are isosceles triangle. So that means that the triangle in the centre where the Venn diagram overlaps must be both right-angled and isosceles. But what is an isosceles triangle? Let's have a look. Here is an isosceles triangle. Stop the video and see if you can write 2 things down that you know about isosceles triangles. Well, of course, like any triangle, the internal angles, that's this angle, and this angle, will add up to 180 degrees. And again, like any triangle, it will have 3 sides. But what distinguishes an isosceles triangle is that 2 adjacent sides are the same length. Adjacent means next to each other. So these 2 sides here are next to each other and they are the same length. The other thing that distinguishes an isosceles triangle is that 2 angles are always the same. And in this triangle, we've got these 2 angles here, which are the same. Now, if you know that these 2 angles are always the same and that the 3 internal angles add up to 180 degrees, how would you work out the other 2 angles in this isosceles triangle? Stop the video and have a go. So let's look at this triangle. Well, if it's an isosceles, I know that these 2 sides are the same, and that angle and that angle both must be 45 degrees. So 45 plus 45 equals 90 degrees. If all the angles add up to 180, 180 subtract 90 will give me the top angle, which is 90 degrees. Have a go at these missing angles, remembering that if you know that angle, you know that angle. If you know that angle, you know that angle. And if you know that angle, you know that angle. Stop the video and see if you can calculate the missing angles. So in this first one, I know this is 28 degrees, and if I follow this system up here, I can tell that the missing angle here is 124 degrees. Similarly, this is 39, that will be 39, so the missing angle here would be 102 degrees. And down here, 48.25, 48.25, the missing angle here is 83.5 degrees. What do you think about this triangle? Is it an isosceles triangle? Why or why not? Well, it is another isosceles triangle. Like any triangle, it has three sides, and it has two adjacent sides that are the same length, and two angles, this one and this one, that are the same. So, if the larger angle on this isosceles is 120 degrees, can you work out what these two angles will be? Remembering, of course, that we know they are the same. Stop the video and see if you can work that out. To work out these angles here, I know that all three angles sum to 180 degrees. So if I subtract the 120 degrees, I'm left with 60 degrees. But I need to divide that between the two bottom angles, so 60 degrees divided by 2 equals 30 degrees. So that tells me that this angle is 30 degrees and this angle is 30 degrees. So let's go back to our original Venn diagram. We've talked about these isosceles triangles. Let's have a look at right-angled triangles. So, any right-angled triangle must have a right angle in it. The right angle will be shown by this little box in the angle that is 90 degrees. Like any triangle, all the angles will add up to 180 degrees. Now, what's interesting about right-angled triangles is they could be isosceles, like this one, which has two adjacent sides the same length, or they could be scalene, like this triangle, which has three sides that are different lengths. Now, here's a right-angled triangle. How would you work out the missing angle here? You know that one and you know that one. Stop the video and give it a go. Now, to calculate the missing angle here, I'm going to write in what I know. So I know this is a right angle, so this is 90 degrees. So far I've got 90 plus 90 degrees plus 35 degrees, which equals 125 degrees altogether. Now I know that the three angles must add up to 180, so I now need to do 180 subtract 125 degrees, and my answer is 55 degrees. Using that same method, have a go at finding the missing angles in these three right-angled triangles. Stop the video, see if you can follow that method. And here are the answers for these three right-angled triangles. The missing angle is 42 degrees here, 61 degrees here, and 47.84 degrees over there. Now this triangle is an equilateral triangle. What can you tell me about the sides and the angles in an equilateral triangle? Well, the name tells it all. All three angles will be 60 degrees and all three sides will be the same length. When sides are the same length, you might find this little mark put across them to indicate that they are the same length. Now, a little challenge. You have a picture here of a right-angled triangle. We know it's a right-angled triangle because it's got the box in the corner. How would you calculate the missing angles in this triangle? And you've got two missing angles. What you are told is the external angle here. Stop the video and give this one a go. Now, let's have a look how we'd solve this problem. Now, I know that the angle around a straight line is 180 degrees. So to work this angle out, I can do 180 degrees subtract 120 degrees equals 60 degrees. So straight away I know that little bit there is 60 degrees. I know this is 90 degrees because it's a right angled triangle. So I can then do 90 degrees plus 60 degrees equals 150 degrees. I need to subtract that from 180 to tell me the missing angle here. 180 subtract 150 equals 30 degrees. So I can now write in both missing angles. Using that method, see if you can find the missing internal angles on these right-angled triangles. You need to find this one first before you can find that one, and this one before you can find that one. Stop the video and have a practice. So this one here, the angle down here is 45 degrees, which means that must be 45 degrees. Two 45s are 90 and that one's definitely 90. The angle here to make up the 180 is 54.5 degrees, which means that this angle here is 35.5 degrees. Now, a quadrilateral can be seen as two triangles. So can you tell me what the internal angles of a quadrilateral would add up to? What is the sum of the four internal angles of a quadrilateral? Well, if I know that they're two triangles and the internal angles of one triangle is 180 and this triangle would be 180, two lots of 180 are 360. So that tells me that the sum of the internal angles in a quadrilateral is 360. So, armed with this knowledge, can you calculate angle X? To calculate angle X, we need to add these three numbers together and then subtract the total from 360. So 100 plus 95 equals 195. 195 plus 60 equals 255 degrees. And then finally, you need to do the total sum of the internal angles of a quadrilateral, subtract 255 degrees, which equals 105 degrees. So angle X is 105 degrees. Now, if you head over to Google Classroom, you will find some activities to practice your learning today. Once again, Entry level is spicy, a little bit more challenge hot, and very challenging would be very hot. These sheets you may not be able to type into because some of them are PDFs. So what I suggest you do is just add another blank A4 sheet below and type all your answers underneath the questions. Thank you very much.